Alright class, this video is on recording or graphing absolute value equations. Okay, first thing we're going to do is look at the graph of y equals the absolute value of x. So I'm going to go to my graphing calculator, go to my y equals, so you have y1 equals. Now to find absolute value, it's in the math button underneath alpha, so you go to math, you move over 1, and then you should see ABS, parentheses. You hit enter, and depending on what type of calculator, you're either going to get the absolute value signs or it'll say ABS parentheses, and then you just put what you want in there and close the parentheses. So if I graph this, it looks like a V, and it makes sense because normally y equals x is a line that goes all the way, well, the right hand side is correct, but then y equals x is down here in the negative. When x is negative, y is normally negative. However, the absolute value changes that. So now whenever x is negative, y becomes positive, and it flips that piece over the x-axis. So that's what it looks like. Clearly, you guys should be able to see that the vertex, which we call where the point is at 0, 0. So let's fill out our chart here. The vertex we have at 0, 0. We would say that this is oriented up. It opens up. So when we talk about orientation, it's how it opens. And we're going to call this shape the parent graph. I'm going to call it the parent because nothing has been done to it. This is our base graph that we deal with. We also might use the word normal. Okay? Now, real quick, I'm going to mention domain and range because we do talk about it a little bit later. Domain is what x values you can put into the problem, and if there's any restrictions. But clearly, if you look at the graph, it goes to the left and right forever. Okay? So we're going to say that the domain, I don't know where I'm going to put this. We can just put it down here. The domain is that x is, and you can write out all real numbers. I'm going to do the symbols for it. It's basically just an R with two lines. Okay, so all the x values you can use. Now if you look at the graph, the range is the output values, or the y's. So let's look at this graph again. Do we have any negative y's? I don't see the graph down here. I only see the graph starting at 0, 0 and going up forever and ever, which means that your y values just are greater than or equal to 0. Okay, so that's what domain and range is. Alright, now I'm going to keep this graph and I'm going to do these two. Let's do one at a time. So I'm going to do 3 times the absolute value of x. So on this one I'm going to do, and I'm going to go kind of quick now in terms of, if you need to pause to see what buttons I'm hitting, just do that. But it's again the absolute value, and then I'm going to graph it. So if we look, now it looks like it's skinnier. Okay? Well, the reason why it's skinnier is we just multiplied all the y values by 3, which ended up pulling it up closer or higher faster. So we're going to call that, well, we'll deal with that with the shape. Vertex is still at 0, 0. That has not changed. Orientation is still up, but the shape is now stretched vertically. It's like, think about pulling a rubber band. Pretend that V was a rubber band and you pulled it upward. It should get thinner, so it was stretched vertically. And usually in this class we'll just talk about the vertical direction. Now, because of that, what do you think the 1/3 will do instead? Hopefully you guys have a good idea. I'm going to get rid of this one and change it to 1/3. Nope, that's not what I want to do. I don't know if I even need these parentheses, but it's good to put them in just in case. Alright, now that's our normal graph. Now look what happened. The y values were multiplied by 1/3 of their original value, which pushed the graph down. So imagine a rubber band that's just stretched a little bit. You push it down so it's not stretched, and it starts opening wider. Okay. Now, what we call that is a compression. So again, the vertex stayed at 0, 0. It's still oriented up, but now this is compressed, pushed towards the x-axis. What does multiplying by a constant do to the absolute value graph? It changes the y values, the output. It either ends up stretching, it either stretches or compresses the graph. And again, think of that as I'm either pulling the rubber band up further or I am pushing it down and it's becoming wider. Okay? Now let's do the same thing with these. So we have x plus 2 and x minus 4. So I'm going to go back in here. I'm going to delete this one. If you guys want to pause the video while you get yours up and running, I think it was plus 2 and then minus 4 down here. So I have to do another. Oh, you know what? Let's do it one at a time. So here's the graph of the regular. Plus 2. Notice how the shape itself is the same, but that the vertex has now shifted over 2 spots. And you can look at the table. Second graph will show you that at if I look at y2 and I go to, notice how when x is negative 2, y2 is 0. So it shifted it over 2 left and then it starts going up again on either side of the negative 2. So that means that we graph that so we can kind of guess what making minus 4 will do. If that moved it to the left 2, this should hopefully move it to the right 4. So there's the original, and again it moved it to the left 1, 2, 3, 4. Alright, so what does adding a constant to x do to the absolute value graph? Adding shifts it left, subtract shifts it right. Okay. Now we're going to do one more. We're going to add and subtract from the outside of the absolute value, and I think by this point you guys are going to guess maybe what happens here, since we just shifted left and right. If I add 4, let's look and see what the graph does. There's the original, and now the vertex has moved up 4 because we're adding to the whole function, not just inside the absolute value. So if I do that again, it will look like it went down 3. So I'm not going to do both of them because you guys at this point can do that yourselves. What does adding a constant to the absolute value of x do? So the whole thing to the function. It's adding shifts it up. Now notice that when it's on the outside, the sign corresponds with what you would think. Positive means it goes up, negative means it goes down. With left and right, though, the signs are opposite. So subtracting will shift it down. And finally, what do you think will happen to make the graph flip over? Well, you guys can guess, but basically, when you add, or not add, when the absolute value of x has a negative in front of it. So this will change the orientation, because then all the values will be negative. Okay? All right, let's do a couple problems of this. First, we're going to learn about the general form so you can always get the vertex and then graph them without actually graphing it on your calculator. So, let's look at this right now. We have a shift. The vertex is shifted 1 right and 2 up. So that means from 0, 0, because that was our parent graph, always starts at 0, 0, we're going 1 right and 2 up. So my vertex is at the point 1, 2. Okay? This number here tells you by what factor you multiply the y's values by. It also gives you a slope. Okay? So the easiest way to graph these, instead of just multiplying all the y values from the original, just take the slope. The slope is negative 2/3, which means this is going to be oriented. The orientation is down. So I'm going to go down 2 and over 3. 1, 2, 3. Down 2, 1, 2, 3. Same thing the other way. That other point is just the vertex where I started before I did my shift. Alright, so this would be the graph. I like to do as many points as possible. And if you're not sure about if this is compressed or stretched, when you look at this value, if it's less than 1, 2/3, it's less than 1, so that means that the shape is compressed. Which makes sense, because when you push it from the up and down direction, it makes it wider. So we would say that that was compressed more. Push down. Okay. Now we're going to do the opposite. Write the equation for the graph. Okay. The first thing that's important is getting the vertex. So I'm going to write that down. It's 3, -4. It's oriented up, so it's going to be positive slope, and the slope is 1, 2, 3, 1. So that means that the value on the outside of my absolute value is going to be 3/1. So I can write the equation y is equal to 3 absolute value. Since the x is shifted 3 to the right, it's going to be x minus 3. Okay. And since it's shifted down, it's going to be minus 4. And that's how easy that is. It's just the reverse of the one above it. Okay. Now we're going to use our calculator to find values, solving in the calculator. Find the corresponding x values for the given y values. So we're going to graph this in our y1 and that in our y2. So it's -8/5. Absolute value of x plus 10 out of the absolute value minus 9.5. And then y2 is going to be -19. We're going to look for where these two lines meet. Now, I see basically nothing. There's something down in this corner. Why is that? Well, let's look at our equation. X minus 10 means the vertex is shifted over 10 to the left, and then -9.5 is down here. So here's the vertex down here, and then it's oriented down. So we're not seeing the graph, and our y2 is -19. We want it to be negative. This only goes down to -10. So this is a place where you need to change your window. Your window will help you find things. So if you go to the second gray button on top called window, you hit that. Our x-min is -10. I want to make that negative like 30 because I want to go way further left. And then I want to make my max, I don't know, 10 will be fine because then it's centered around -10. My y-min, that's how low I want to go. Well, since the y-min is at least -19, I'm going to say -25. And then the y-max, it's never going to go higher than -9.5, so I'm just going to say 0. Now I should see my graph somewhere down here. And there it is. And there are the 2 points. Once you have the sketch, and I do want to see the work that you did here because I can't actually see your calculators on tests and quizzes, I would want you to say that I had a window of x-min of -30, x-max of 10, y-min of -25, and y-max of 0. And then the window would look something like this. You could say this is -19, -9.5, and literally I just need a sketch at this point. What did you see? We saw a graph that looks like this. I need to know what these 2 points are. Okay? To do that, you go to second, and then you hit trace, which is the 4th gray button on top. And then if you notice, it says there's a thing called intersect, which is number 5. So we hit enter on that. My cursor's up there. I'm going to hit down once to get on the other line, and then I'm going to move over towards that point I want. That's close enough. Hit enter 3 times, so it kind of estimates it. And you get that when y is -19, one of the answers is -15.938. It said round to the nearest thousandth. That's 3 decimals. So negative 15.938. So x equals negative 15.938. The point here is negative 15.938 comma negative 19. And then we have to do it one more time. So we can go right to second trace 5, hit down to get on that line again, because it always starts at the y1. It's faster just to go on that line there. And the other value is negative 4.063 when you round to 3 decimals. Negative 4.063. And again, we got that from the point. So that's how you use your calculator to find values. When you have two equations, put one equation in your y1 and one equation in your y2 and find out where they hit each other. Okay? Alright, final problem. The front of a roof with its outer edges 8 feet above the ground can be modeled by this absolute value graph. Graph the function, interpret the domain and range. Well, you guys should be able to tell me that the vertex for this function is at 9, 14, and the slope is negative 2/3. And that makes sense because it's oriented down. If the absolute value graph is the roof, it is oriented down. And we only go till y is 8 feet above the ground. So, right now I'm at 914. Then you go down 2, so we're down to 912, and over 3, so we go to 612 is the next point. Then we go down, I probably should erase this line because I don't know where the 0 is going to be. Then we go down 2, so we're at 10, and over 3, so we're at 310. And finally we go down 2, which is 8, and we go over 3, which is 0.8. So here's the edge of the roof. And then it follows suit the same thing over here. So it goes 0, 3, 6, 9, 12, 15. This is going to be 18, comma 8. This is going to be 12, comma 12, and 15, comma 10. So those are all the points, and you can use that calculator. I just did it quickly because I don't want this video to go any much longer. Interpret the domain and range in this context. Now clearly, if you graph it on your calculator, it's going to go forever. It's going to look like this. However, it's a roof. And I know many of you guys' roofs don't go into the ground. Okay? Or roofs, I should say. So, then we can just say where the domain and range are. What are the x values between? Well, the domain is that x is between 0 and 18. Once we get past 18, the roof isn't there anymore. The range for the roof is, it's a minimum height of 8, and then the maximum height is based on the vertex, which is 14. Okay, so that would be the roof problem.